Uh, Welcome to functional reactive programming in C++. Some usual stuff at the beginning. My favorite quote from Phil Wadler, which I show every conference so far. You should make your code readable because the next person that sees it and has to work on it might be a psychopath and he knows your address. So you should write your code so that other people can read it without any problems. The second disclaimer, although in this presentation I'm not going to show that much code, we are going to focus on software design mostly. Slides are not really optimized. It's just code for you to see, not something that you can copy and paste and use in your projects. You should probably optimize them. Now, one of the things that people who already saw me speak, you got accustomed that I start the presentation by showing the monument at the Trap Tower Park. This time I'm going to change it a bit. So instead of the Trap Tower Park, I'm going to show a couple of functional C++ people in the Red Square. In Moscow, it was a conference a couple of years ago. If you don't recognize any of the faces, yeah, you should. So we are going to play a little game later on. When somebody sees the red square pops up again in the slides, raise your hand and shout red square and you'll get a gift. So, okay. We're going to start with functional design. A couple of things before we can move on to the reactive stuff. So one of the things that you usually hear about functional programming is that they have higher order functions, that they don't like mutating variables and stuff like that. But you rarely hear why and how you can actually develop software without changing any state. So as I said, we are going to focus mostly on design now, and we are going to skip all the nitty-bitty code details. So C++ was functional from at least from the 98 when it was standardized. Higher order functions are functions that can take another function as the argument, or functions that return new functions as the arguments, as the result. So ever since we had findIf, ever since we had bind first or bind, we had higher order functions in the language. So the language, even without lambdas, without std function, was already functional, kinda. So you were able to develop your software in a functional style. Essentially, the only thing in C++ that is required for it to be considered functional is that it has the call operator, that you can overload the call operator. And if you can do it, then you can create things that look like functions, even if they are not really. So why are higher order functions useful? A long time ago, in '86, the great Donald Knuth was asked to develop a program for one of the ACM journals. And the program was supposed to read a text file, extract all the words, count all the words, and just print out the words that are most frequent, along with how many times the specific word has been in the file. And after a while, Knuth sent a solution. Solution was 10 pages long in Pascal, and it was well documented. It was beautiful code, and it was really, really, really pretty. It had some novel data structures developed just for this example and everything else. And it was customary for this journal to ask another scientist to provide a critique of the original of Knuth's work. And Doug McIlroy just sent a shell script that had 6 lines in it. So instead of 10 pages, you use bash or Z shell or whatever existed back in the 80s, and you do the same in 8 lines. 6. Is it as efficient as Knuth's version? Probably not. Is it not efficient? It's not. It's still really, really performant. Now, this is something that demonstrates why functional style is really good. Instead of writing your algorithm step by step what you should do, you just create a series of transformations. You have your input, and then you just think of which transformations should I apply in order to get the result. So you can just imagine a conveyor belt in a factory, and each transformation is another machine that transforms your input. If you wanted to convert the shell script to C++, it will look something like this. So first, we have the data, and we want to ignore spaces, commas, semicolons, and everything else. So we're going to apply data, should be transformed so that each character, if it's a letter or a number, then leave it as it is. If it's not a letter or a number, then replace it with a /n. So what we are going to get, we're going to get words separated by /n's. Now the next step, capital letters can confuse our algorithms when we compare words. So we also want to do a transform to convert all the characters to lower. And now we get the new block, words separated by /n's, that are all lowercase. And this is pre-processing part. Now we do the actual work. So we can split, use the /n, the new line, as the splitter. Obviously, we need to ignore the empty results, the empty strings, if we can have consecutive /n's. And we will get a list of words, or a range of words, to be more precise. The next step, then we can sort them and group them. So when we sort them, all the same words will be grouped in the original range. Now we want to split that original range into a range of ranges, where each of the sub-ranges will just contain a lot of A's, a lot of A's, AS, and Ets. Now, instead of the starting text, we just have a list of grouped words. The next step, we don't really care that we have A. We need the number of A's, and we need to remember which word it was. So again, we call transform, and return make pair how many items are in a group. That's the first, and the second will be the first word in the range. What are we going to get? We're going to get a list of pairs, frequency, word, frequency, word, frequency, word. Now we need to sort them, and because sort is ascending, and we want the other way around, we get reverse and say take 2, because we want just the top 2 words. So the whole program in C++ is a little bit longer than in Bash, but it works really well. Now, here we have a couple of issues. We might need to optimize sort group by can be implemented in a more efficient way than actually quick sorting everything and then grouping. But again, we can create a transformation that does exactly that. And the second problem that we could have here is that we are sorting. So we are sorting the whole collection and then taking just n items, which is, again, not efficient. But who is to say that this sort is eager sort that actually sorts the whole collection? You can implement sort in a lazy way. Instead of sorting the whole array, you just remember I have the array, and when you say take n, it needs just to sort the beginning of the array. Okay? Is it all right? I guess everybody would have some idea how to implement lazy sort, but it's not really that difficult. As a quick sort, you just need a pivot. That's the only time that you actually have to process the whole array, and then just process the first part. And if n is, again, less than that half, pivot the first part. Pivot the first part until you get just exactly the n items that you need. Okay, so this is why higher-order functions are really useful. And the basic idea of functional design, how you should solve your problems just as a composed series of different transformations. Now, the next thing that is usually connected with functional programming, although I'm not a purist, so I don't really consider it essential, is that all functions should be pure. What does it mean? You should never change state. You should always return the same result given the same set of arguments and so on. If you want to define it in a more precise way, you can say that function is pure if, when we call it, it's referentially transparent. If we can replace the call to the function with the exact value and not to change the result, the behavior of the program in any way. Now, is this function int answer, is this a pure function? If we replace answer with just the value, we're going to lose the stdcout part. So if we consider stdcout to be something really important, the output, then this is definitely not a pure function. If we replace the answer with the value, we have changed the behavior of the program. Now the problem with this definition is that anything that you do on the computer changes something. At least you're changing the processor registers. So no function that ever executed on any computer can be pure. But then you have to set a boundary. What is observable to you? If you think that processor registers are observable, then nothing is pure. If you think that they're not observable but stdcout is, then this is not pure. But if you don't care about stdcout, you can say this is pure. So the problem with the definition is that you can set the boundary wherever you want. Obviously, some boundaries are less useful, like registers, or everything can be ignored. But it's up to you. Now, why are pure functions good? The idea of depending only on the arguments and not on the state. Just imagine the example, the user who is logged in on the system clicks something, and then you have to show a dialog and load all the team members into a table. The first thing that you need to, okay, the user clicks, then the first thing that this function does sets visible to true. So it shows up the window. The next step, it connects to the database, loads the data, and fills the window in. Now, since the user is logged in, and we want to load her or his team, then we need not only the arguments to the onClicked, we also need to take data from the state. And then again, since the window is the part of the state, we get a really tangled web of dependencies here for a really, really simple example. Instead of that, the functional programming tries to be somewhat different. One of the problems is that not only functional programming should be different. There are a lot of object-oriented people who think that most of our code is completely wrong. Essentially, you should never have a getter. Instead of getting the data from somebody, you should just ask him to do something, which is much easier for us, right? Instead of doing the work, just ask somebody else. So don't ask for the information, you need to do the work. Ask the object that has the information to do it for you. And this is inspired by object thinking, one of the big books for object-oriented design by David West, and one of the favorite quotes is that the first step, if you want to forget getters, so you don't want to be a procedural developer anymore, you need to have a lobotomy to be able to think in the object style. And again, some of the conclusions from the object thinking is that when you start thinking like this, your objects tend to become immutable. And although not immutable in the sense that functional programming thinks. So as far as object thinking is concerned, you should never change the object from the outside. You can ask the object to change itself. So for example, one of the examples here was you get a car in real life, can you say set height 5? No, the car is already there. You can't really change its height. You can give it to a mechanic and then he can do something with the car, but the car itself cannot change its height. So one of the things that we usually do is that we can change the object from inside, we can change the object from the outside. And as I said, object thinking guys don't like this arrow that comes into the earth and is from the outside. In functional programming, this is not allowed. You can't, if you want to be pure, you can't even change the object from inside. So then what do? Everything in the world changes, right? And what do is something that was kind of known in ancient Greece and is a really, really popular thing in sci-fi. Whenever you make a choice, you don't actually change the world. You're creating a dozen of new ones. One world where you made a choice, another world where you made another choice, and so on and so on. So this is a couple of references to parallel worlds in SF and some even serious films that are considered SF. So instead of changing the world anytime that you want to, you just create a new world that is a little bit different. Okay? So what's the point? Is this expensive? Is this efficient? We are copying the whole world every time that we want to change something. Now, you have a couple of options. One of the options is the option 2. You can use the immutable data structures, which are developed with the idea in mind that you can't change them, but you can, in optimized way, create slightly different copies. And that's something that I might talk next year at Meeting C++. I haven't decided yet. The other approach is just to forbid copies. Unfortunately, in C++11, we can say ampersand on the end of member function declaration, which means this function will only work on temporaries. You can't have a variable and call dot with population. So if you want to use the API that's designed like this, you can't call world with population 6. You need to explicitly state, I don't care about the old version, about the old world. Just move world dot something. It creates a temporary, well, converts kinda the old world to a temporary, then creates the modified version and returns as a brand new world, and the old world is just forgotten. So no copies involved. And the good thing here is that if we do this, then compiler enforces us never to actually make a copy. Now, sometimes copies are useful. For example, for debugging, if you have all the previous worlds, it's kind of useful to just scroll back and forwards to see what happened. It's also useful, Sean Parent talked about Photoshop in Moscow, and he said that they are actually using immutable stuff in Photoshop itself. Your document is always immutable. When you want to change something, you create a new document. If the user chose to save the document and continues working, it's easy. The old version is being saved while the user creates a new one. So it's not like purity and immutable data structures don't have anything to do with object-oriented programming. Photoshop is not a functional program. It's mostly object-oriented, but uses some of the great ideas that come from functional programming. Okay, so we can do time travel if we remembered all the previous worlds. We can test different possible scenarios in parallel. We can even communicate between the worlds if that's your thing. One of the great examples is our genetic algorithms. You essentially have a dozen of worlds, choose the most efficient ones in some sense, and then combine them somehow to create new worlds. So everything here has a lot of application, even if it's not really obvious at first. So this is the basic part of the functional ideas. Now we are going to switch to what reactive is. Now, this is definitely my favorite text because it's completely useless. if you search reactive programming, you're going to first encounter Reactive Manifesto, because manifestos are really, really, really popular nowadays. And you'll have a lot of words inside that don't really mean that much. And yeah, it's almost all buzzwords. So it's probably not meant for us. It's meant for marketing guys and everything. So let's skip the Reactive Manifesto a bit and just focus on the things that reactive guys, the most popular ones, being from Akka library and Arix, former Microsoft extensions. The idea is that you should write your programs that respond quickly, resilient to failure, responsive under workload, and that's something that you usually do even without any reactive programming, right? It's not like any of these things are not really obvious. I shouldn't write my code that if something fails, my whole application crashes. So, yeah. The only maybe novel idea here, although, again, not that much, is that everything should be based on message passing. Or, as we like to call them, event loops. Again, so we all already do reactive programming, just in a different way than functional reactive stuff is supposed to be. So, we are showing, this is an Oxford Dictionary definition of reactive. The idea is that we are just responding to something, reacting, not replying. Okay, let's skip this. So you shouldn't ever call a getter, because it might block you. If the getter is slow and you need the data, then you have to wait and wait and wait, which is definitely not a good idea. Instead, you should just ask somebody to do stuff for you. So all the communication should be just in one direction, never in the other, which will be a little bit of a problem, but not much. Let's consider our former example. And now just don't think of these as transformations, but different people in the chain. You have one person who just yells letter, 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 letter. So it's like a series of messages that are characters, okay? And then the first person listens to the letter, checks, okay, it's really a letter. I'm shouting the letter and passing it on. If it's not a letter, I'm just shouting new line, okay? And the next person comes in line and hears, receives the message, passes it on. And all the people just pass on, and never return the value to the first person. Now, in this case, we have a bit different people here. The first two alphanum or two lower transformations are essentially simple. You get one message, you pass on one message. The split is a little bit different. That guy has to be a little bit smarter. He needs to actually remember all the letters that came to him until a new line. So you get a dozen of messages and emit only one that will be composed from the old ones. And the smartest guy here has to be the sort, because he needs, or she needs, or whatever, needs to remember all the words and then sort them and push the result when everything is already done. So essentially, the first three guys are really good for reactive, the last guy isn't. Because you can never count on whether the character stream will ever end. Maybe somebody just picks a random characters and sends it to you. And if you put a guy like sort that needs actually to have all the data before it continues, then you're not reactive. It's just damned, and it stops all the streams outwards. So, just a small example. And this is the only demo that I think will start. Because since this is called functional reactive programming and it's FRP, which is fantasy role-playing, then we're going to have just a small example of a reactive, completely pure program that is kind of a dungeon. So we have a couple of items that are moving, and I lost. No problem. So the idea here, obviously, the game is really stupid, but it's something that screams object-oriented, because you have components that are moving and changing all the time independently from one another. But this is not object-oriented. What are we doing? We have inputs, we have the old world, and we have different functions that represent different objects in the scene. And all of them create a new world as a result. So if somebody presses an arrow key, then the king function will react, and it will create a new world where the king is moved a little bit. Now, if we want to show what the design of this thing is from the transformation view, we have keyboard events, so a series of events from the left. Then, if it's arrow keys, filter arrow keys and then pass it to the king. If it's as DW, then filter on those and pass those keys to something that looks like an elf. And if it's a time-based event, then you want the AI of the baby to kick in and generate the moves for the baby. Then you just join all those streams, and what you get, filter by valid moves, and then pass it on to the world. So we have completely different components that are completely separate from one another, and they work really well. So the idea is that when you design your objects, functions, or components, you should never have any shared state. At least not mutable shared state. And if you don't mutate your state, even if you're sharing, then you're safe. You don't need to use mutexes or anything else. So the second thing, the components are isolated. You can communicate only through message passing, and that's it. And we have a couple of different, we don't always have a person who receives a message. You can have a person that just yells out without actually receiving anything. And again, you can have the consumers that just listen to the messages and never respond. So the silent type down there, and the I don't know how to say it in English, in the create. And process is the most common one. And this should be obvious. Okay, so what can you design as a series of messages? You can design web server requests. You can, when you ask a database for something, it can return the rows as messages instead of blocking your process until all the rows, well, each row is retrieved. When the database is ready to send you the data, it will send you the data. And then you just need to react. Essentially, you can model almost everything just with series of events. And the good thing is that you can even consider std vector, std map, or any other collection to be a series of messages. It's just, the difference is normal messages, just you don't know when they're going to come. And with std vector, you already have all the messages available. But again, it's just a series that you can traverse through. So you can use all the usual range transformations like transform, filter, take, drop. You just shouldn't use things like sort, which we already mentioned. Okay, and now a small demo that doesn't work. So you're going to have to listen. I'll try to explain what the demo should be doing. It looks like this. So we have a couple of objects in the window, and we want, when the mouse moves, we want to move those objects according to something. Okay. So one of the okay, I don't really see. Okay. So he noticed the red square because there is a red square, and now just a really short diversion from the presentation. One of the things that I always found really classy is when the presenter has a book and he gives it to the audience when they ask questions. And unfortunately, I don't have a book yet, but it's in the process of being written. And it started as an early access program, so a couple of chapters are already available and will be available further on. So I have a couple of coupons which get you the book for free. And can you just, come here. So the coupons are essentially a folly future of a book. So it's not yet ready, but when it is ready, you'll get the value that is stored in the future. And do you know the reason why it's a folly future and not STD future? Okay, I need a little bit more detail. Essentially, what does STD future do when you call a .get? It blocks. So if he tried to call .get on this paper, he would block the whole world, including me, and I would not be able to finish the book. So this is a folly future. He'll get just an exception thrown at his face that book is not ready yet. Okay, now let's try to close this window in Ubuntu. Huh, success. Okay, so now we have a red square, and we want the red square to move whenever we move the mouse. If we use the range notation, we could just take the mouse stream, so the series of events, and directly connect it to mouse cursor, which is that red square, and connect to a sink that's called move_to. So whenever a new message pops up, it will contain the coordinates for the mouse, and the red square will move. Okay? Now, the next step, we want the green dots are rulers, like in, again, Photoshop or Inkscape or GIMP. When you move your mouse, you want the coordinates to be shown on the top and the left of the screen. What can you do? You can say mouse stream, I want it transformed. I don't want both coordinates, I just want to project it on X, and then say move_to. So project function is quite trivial, just replace X coordinate with a const or epsilon coordinate on const, depending on the axis that you want to project to. But if we do this, we just lost the ability to move the red square. So now we want to somehow fork our stream. Instead of having a stream that goes through a transformation, we want to fork it, and then we can send it to different listeners. One of the possible approaches is, like in Bash or Z shell, to use the command that's called T. Does everybody know what T does in Bash? Okay, so it essentially gets the lines, or in this case messages, passes it on to its argument, and then passes it on to the rest of the chain. It's a really useful tool for debugging. It's not really useful for general stream forking. Instead, what we could do, if we wanted to do a real fork where we want to have more transformations applied after the fork, we can use the fork. And then you pass all the receivers of the message that you want to have. In this case, so we have T that moves the mouse cursor, then we are forking the stream. One fork goes through projecting on X, one fork goes through projecting on epsilon. Okay? And when we move the mouse, now the red square moves and the green dots move. And now, unfortunately, the main star of this example is the big blue circle, which is not really easy to explain what it does without a demo, but let's try. When you move the mouse, it should try to follow it, but it should never reach it. It's like it's trying to come close, so it needs to remember the previous position, it needs to know the current mouse position, and to calculate some coordinate in between. Okay? Now the question is, as we said, these are completely isolated components. They might live in different threads. And this thing should have a state that is mutable state. And this thing is not implemented in a pure way. It's really mutable state in object-oriented sense of the word. Is it safe? Is it safe to do something like that? We have a mutable state in a multi-threaded environment. Are you sure? On what? Absolutely no synchronization mechanisms in this program. It's not, somebody said, it's not shared state. Essentially, it's completely safe to have mutable state if you're not sharing it. Essentially, of all the quadrants, immutable, not shared, shared, immutable, and everything else, the only dangerous one is when you share and mutate. And somehow it's 99% of all our code. And it's just, it should be 1/4, right? So if you don't share something, you can mutate it as much as you like. You don't even need to concern yourself with purity and creating new roles and everything else. The components are isolated, you can do whatever you want in them, as long as, obviously, if a single component doesn't spin off multiple threads, which would be quite insane. So, again, although the wrong name, transform project X, transform project epsilon, and transform instead of map, gravity object. These functions are usually called map unless you're working in C++. Okay, so the next thing, we also have this crosshairs thing, and it should move only when the epsilon coordinate is divisible by 100. Unfortunately, again, you can't really see it, but just imagine I'm moving the mouse, and it just moved here. How can we do something like that? Again, just like with ranges, you can filter events. You can just filter on a predicate epsilon equals, epsilon percent 100 equals to 0. And then you ignored a lot of events, you just require a particular set of ones. Now, one of the bugs that you would see is that if I move the mouse too quickly, this thing will probably never be updated. Any ideas why? Yeah, essentially, we are catching exactly when the mouse is, well, the epsilon coordinate is divisible by 100, and it doesn't need to happen ever, because the mouse might jump from 99 to 101 or something even longer. And again, we can create something that will create continuous series instead of having the gaps. And okay, so we can create a transformation that takes one message. It has its previously saved state, so the previous coordinate, and generates a series of events. So you can do it with a Manhattan or something more complex. You just need to be sure that all the pixels are hit. And now, since we are returning a vector of points and getting a point, we can't really use transform anymore, because it would create a stream of streams or a range of ranges instead of just range of points. So instead of using transform, we need to use transform and flatten, or as it's usually called, flat map. What does it do? For each event that you get, this will create a vector, and flat map will return each element of the vector as a separate message. Okay? So we have completely separate components to reiterate the most important parts. We have transformations that are as useful as ranges, just a little bit more generic because they work on the data that is not yet here. And the main point is that the design of your software is where the asynchronous execution is built in. You can't design your software like this and then block anything. If you manage, then you're really, really gifted. But that's not all. If the components are completely separate, then we could even... Okay, that's the at least the 20th time that the red square appeared, but who said it? Okay, here we go. So one of the things, if you have different separate components, you don't even need to keep them in the same process. You don't even need to keep them on the same host. If you have any kind of way to serialize them and send them over the network, the same design of your software will apply for a distributed system for anything else, because you never made an assumption that anything is synchronized. And now the demo would be two different windows, where I move mouse in one, and some of the objects move in that one and some in that one. But again, a colleague of mine doesn't have Qt. So now usually all the things that I talk about are never implemented by me, but usually by some other people who listen to my talks. This thing will at some point become one of the KDE frameworks when I get the time to actually finish it. The idea is KDE has a search mechanism that has a lot of plugins, and plugins can crash because people who write C++ and third-party people don't really care about crashing user systems. So one of the reasons why I started this project is that I want the interface to work normally. If a plugin crashes, it crashed in its own process. It doesn't concern any of the other parts of the environment. If you want to investigate currently existing libraries, higher level library, RxCpp, that's the thing that initially came from Eric Meyer while he was working at Microsoft. It's a nice library. It's a little bit too object-oriented, so unlike what John mentioned yesterday, it's not Alex Stepanov design. And if you want lower level message passing and actors and stuff, you can use Objectizer. It doesn't currently, I think, they removed networking support, which is really sad. C++ actor framework, which is a lot of people design, a lot of persons that communicate through messages, and obviously ZeroMQ. Although these are all, these three ones are really low level, so you don't have the filter, you don't have any of the abstractions. You would need to build them by yourself on top of the lower level libraries. And that's it. 5 minutes. Any questions?
So please come here to the microphone.
So one of the things that struck my eye in the beginning with that C++ shell program was that we were doing like 10 passes over the same range. So I was thinking that for very large inputs, I could, if I tried hard, I could probably compress that to 1 or 2 passes. So where does this become inefficient?
Do you really think that it does 10 passes? It doesn't. All the ranges, when you call transform, it will not actually go through the whole range and transform. It's at least the ranges v3 and boost range. They implement it in a way, when you ask for the result, then it will get calculated. So when you call sort, then it actually needs all the values. So it will ask, what's the value of the first one? It will go, this function should be applied to this element. So until the first sort, you have just one pass. Then you sort, and then you again have just one pass. Okay. Fortunately, people who are working on ranges are really, really, really smart, and they are well versed in functional programming, where this is a common pattern.
Hi. So from what I understand is that from the mouse stream, every event will be executed or processed. And is there a way to skip the one like when the process is not finished, and you just skip them, the extra events, so that you can keep the frame rate? Is there a signal?
Okay. Now, there are a lot of more complex transformations like debouncing or stuff like that. So with them, you could use it. You could achieve something like that. Again, I haven't really thought about the thing that I'm working on doesn't really care about mouse. It just cares about rare messages. For mouse, you would use a debouncer or something like that.
Because I have something similar, and it's actually an image stream, and I process these images. And sometimes the process can take longer than the frame rate, and I want to skip some of the image stream so that I can keep the frame rate for it.
I do understand the point. It's just something that I haven't considered because I don't like over flooding with messages. But
Yes.
debouncing, and I completely forgot the other term. So the debouncer could just ignore until I want a new one.
Yeah.
Or there are also options like wait 100 milliseconds after the last one and stuff like that. So those can be implemented and combined to probably solve your problem.
Thank you.
Hi, Ivan.
Hi, Rainer.
Did you try to implement it with your word count example with regex iterator and regex and put it into a map and do it the classical way? What's the performance difference? Did you try to implement it in the classical way?
No, because I'm not feeling masochistic.
That's not masochistic. That's my first example for motivating a seminar in C++. That's not masochistic. It's a different way, of course.
The word frequencies.
Yeah, it's a five-liner.
Yeah,
It's a five-liner. Really.
essentially, I don't like doing things that I don't need to.
Yeah.
And
I was only curious.
for me, this is really the best example for the ranges. So I would never even try to implement it like Knut did. But thanks.
Hi. Just out of curiosity, how many red squares did we miss in your talk?
Well, I was just expecting that you saw the first one because it's only in the example. And whenever I showed the example, there was a red square.
Hi. How do we mix parallel programming and the functional programming? Because in the example, we have series of transformations. So can we parallelize it?
So essentially, if a function is pure, then they can be evaluated in whichever order you want. But if one function takes a result of another function as the argument, then you can't. You have a serialized dependency tree. So in this case, if we have one transformation that needs the input from the first one, it actually needs that input in order to be able to do something with it. But it can be in, I don't want to say separate thread, but it can be concurrent, so that while this one generates a new event, this can process the previous ones. And that's one of the main points here, is that it doesn't matter, is it on the same thread, is it on multiple threads, multiple computers, multiple fibers, whatever. Something can be executed on the GPU, something on the CPU, completely independent from one another. It's just that you need the data to be able to actually perform something on it. Can the first three people who asked questions come afterwards? Because I forgot about 3 more future books. Okay, so thank you.